Okay, so in the last class we discussed, was the first class for polynomials, and we discussed what is a polynomial, and we also learned how to do the long division, how to divide a polynomial by a polynomial, and how do you write it at the end. And we also discussed that if the after division, if the remainder is zero, this tells us that the divisor, the thing which you are dividing, it is a factor. A factor completely divides another thing. When something completely divides another thing, the remainder, there is no remainder. So if you are getting a remainder, this means that your divisor is not a factor. And if your remainder is zero, this tells us that the divisor is a factor. So we will use this logic later properly again as well. But right now, to strengthen the concept of the long division, we have two equations over here. Sorry, two questions over here for practice. So they have given you to, they have asked you to divide x power 4 plus 3x cubed plus x square minus 2 by a quadratic factor or divisor x square plus x plus 1. So the logic will be the same. First of all, you choose the first term of your divisor x square, and you will see that you will have to multiply x square with x square so that it becomes x power 4. So this becomes x power 4, and then you will multiply the rest of them with the x square. So this would become plus x cube and then plus x square. And then you change the signs for all of them. So this becomes minus, this becomes minus, this becomes minus. And then you add them. So x square minus x square, sorry, x power 4 minus x power 4 cancels out. This becomes 2x cubed. And this also cancels out. X square minus x square. So this also cancels out. And minus 2 would be carried forward. And now you will multiply the x square with 2x only. So that you will get 2x cubed. So this becomes 2x cubed plus, now you multiply the x with the 2x. So 2x square and then 1 with 2x. So plus 2x. And then you again change the signs for each of the terms. So this is minus now, this is minus, this is minus. And then this cancels out, minus 2x square, carry it forward, drop it down, minus 2x square, minus 2x, and minus 2. And now you see that you just have to multiply the x square with minus 2. If you multiply x square with minus 2, you will get minus 2x square, and then you will get minus 2x, and then minus 2. You can change the signs.
So 0 आ जाएगा आपका, that means it's a factor.
0, 0, 0. So our remainder is coming out as 0. So you will say that this was a quadratic factor. It's a quadratic factor therefore.
ठीक हो गया.
Okay. Then we have another equation. Sorry, another question. Also similar. They're asking you to find the quotient and the remainder when fx is divided by. They have given you fx. This x cube plus 3x square plus 4x plus 2. And this thing is divided by x square plus x minus 1. So you will multiply the x square with only x.
X और फिर ये x cube हो जाएगा, उसके नीचे आ जाएगा x square, so that will be 2x, and इसके नीचे आ जाएगा 1x, so that will be mine.
Yes, and then change the
5x.
sign. And then you add them, so 0.
2x square and
plus
then 5x
then carry forward the
plus 2.
plus 2. And now you will multiply it with
2.
So 2x square
2x square plus 2x minus 2, तो ये प्लस हो गया, 2 माइनस हो गया, that means के 3x plus 4.
And that is it.
ठीक हो गया.
So you will write it down. The quotient is the part of x plus 2.
Quotient is x plus 2 and remainder is 3x plus 4.
3x plus 2. This is it. Now the second part, use the factor theorem to show that x plus 1 is a factor. Now this is something which is the new. We don't know about this. This is the new topic. So what is this one? So now we know how to do the long division. Why is long division good? Long division can help you check if it is a factor or not.
Hmm.
It can help you find the remainder, and it can also help you to find the quotient. So this is the complete package. It will help you. If you only know this thing also, you can solve all of the questions, almost all of the questions, 95% of the questions are passed. But there's another one more thing that is that is included, which is the remainder factor theorem. What is this? This theorem tells us that if you have a function, if you have a polynomial fx, now this can be any polynomial, cubic, quartic, anything. If it is a polynomial, anything, and they have given you a divisor, they are asking you to divide. Divisor is x minus a. So this would mean that f a, if you input the value from the divisor into the function, this will get you the remainder directly. And if f a is equals to 0, means the remainder is 0. And so therefore, the x minus a is a factor. Now how do we do this? So if we take the same question, let's take the same question. They are asking us to check if x plus 1 is a factor or not. So the divisor is x plus 1. And the function is, the polynomial is this thing. So if I write it down, fx is given to us x cube plus 3x squared plus 4x plus 2. And then look, if the divisor is x plus 1, what would you do? You first of all find the value of x. So x plus 1 is equals to 0. You solve for the divisor value of x, and then x will come out as minus 1. And now if you input the value of minus 1 over here, the value from the divisor into the question again, and then use your calculator. See what do you get. So you would get minus 1, 3, minus 4, and plus 2. So how much would this be? 0. I think 0. Minus 5 plus 5. So 0.
0.
This is telling us that the remainder is 0. And if the remainder is 0, this means that x plus 1 is a factor. So the remainder factor theorem can directly, without any long division or without any critical working, it can directly get you the remainder for whatever the divisor is. So the benefit over here is remainder factor theorem. This is quicker and shorter, less working. Gets you the remainder. But the problem is, it will not get you the quotient. After dividing something, it will not get you the quotient. Quotient, if you need the quotient, you will have to do the long division. Because this part is the quotient. The remainder factor theorem can only help you work with the remainder part. If it is remainder is 0, then it is a factor. If it is not 0, then it is not a factor. But this is more quicker, more shorter working, less working. So depends on the question. Right now, we could have also done the long division with this divided by this divided by this, and the remainder after complete thing would come out as 0. That would also tell us that this divisor is a factor. But the problem is they are asking us to use the remainder factor theorem, the factor theorem. So this was the factor theorem. So you get the value of x from the divisor, you input it back into the function and find the value of the function. And the value of the function is that remainder. And if the remainder is 0, the factor. Okay? So they can ask you to fully factorize something. Let's see. Okay, here it is. So they have given you a polynomial in which there is an unknown a, we don't know a. And it is given that 3x plus 1 is a factor. Is a factor. Now we know that when something is a factor, the remainder will be 0. So over here, to find the value of a, we can do long division. As well, we can do the remainder factor theorem as well to find the value of a. But the shorter method is definitely the remainder factor theorem, because you know what is the remainder. So if your function is this, let's suppose fx is equals to ax cubed minus 20x squared plus x plus 3. So if I find the value of x from this divisor, you will get x is equals to, or 3x plus 1 is equal to 0. And so x will be equal to negative 1 upon 3. So you will say that if you find the value of the function at 1 upon 3, negative 1 upon 3, it will come out as 0 because it is a factor. So your equation becomes 0 is equals to a negative 1 upon 3 q minus 20 negative 1 upon 3 whole square plus negative 1 upon 3 and plus 3. And then you can use a calculator. Negative 20 negative 1 upon whole square and then minus negative 1 upon 3. So negative, and then you have plus 3 as well. 4 upon 9. So this would be equal to 0, negative a upon 27 and plus 4 upon 9. So a upon 27 equals to 4 upon 9. And then therefore a would be equal to 4 multiplied by 27 upon 9. Is equal to 12. So the value of a is coming out as 12. That's it. Do you get it?
जी सर, इसके अंदर बेसिकली हमने उसकी जो वो है एक्स की वैल्यू निकाली। अब एक्स की वैल्यू को जब हमने एफ ऑफ एक्स के अंदर डाला तो हमारा आ गया 0, क्योंकि वो एक फैक्टर है, उन्होंने कहा हुआ है।
Yes.
जब फैक्टर है तो फिर हमने उसके अंदर एक्स की जो हमारे पास मेन है ए एक्स क्यूब वाली एक्सप्रेशन, उसके अंदर हमने डाल दिया -1/3 वहीं पे, और उसके बाद हमने ए की वैल्यू निकाल ली उसके थ्रू।
Yes, yes.
समझ
And
आ
then
गई?
when a has this value factorized. So this means now the equation has become 12x cubed minus 20x squared plus x plus 3. Twelve x cubed minus 20x squared plus x plus 3. And then now you have to factorize. So this is a cubic equation. Whenever you have a cubic equation, you have 3 factors. A quadratic equation has 2 factors. A cubic equation has 3 factors. And if it is a quadratic equation, you will have 4 factors. So you already have one factor, 3x plus 1. This is the first factor. They've already given it to you. Now you need the other two factors. And to find the other two factors, you would need the quotient. But the what do you say? Remainder factor theorem does not give you the quotient. So the remainder factor theorem has only helped you in the first part. So to get the quotient, you will have to do the long division of the equation that you have the curve, and now you will divide it with the factor, the first factor that you have, 3x plus 1. And this would help you to find the quotient, which will have the other two factors which you want to find. So this would be multiplied with 4x squared. So I will quickly do this. 4x cube plus 4x squared. Change the signs, add them, minus 24x squared plus x, and then minus 8x, so minus 24x squared minus 8x. Change the sign, add them, 9x plus 3, so plus 3, so 9x plus 3. Change the signs, add, you will get 0. So look, your remainder is 0, and this is this quadratic quotient. If you factorize it further, you can factorize it using middle term breaking. You can do 6 times 2. If you factorize this, it would become 4x squared minus 6x minus 2x plus 3. So 2x common, x minus 3, and minus 1 common, x 2x minus 3. So 2x minus 1 and 2x plus minus 3. मुझे क्यों लग रहा है I made a mistake? Okay. Okay, yes. So this means now that the three factors are what? You found the first factor they had already given it to you. It was 3x plus 1. And the other two factors you got after factorizing the quotient. So 2x minus 1 and 2x minus 3. Okay, this is the answer to your third part.
ठीक हो गया सर। इसमें हमने पहले उसकी वो लॉन्ग डिवीजन किया, लॉन्ग डिवीजन के बाद हमारे पास जो ऊपर इक्वेशन आई है उसकी उसको हमने क्या किया?
Long division से quotient आया, the quotient after the long division that comprises of the other two factors.
ठीक हो गया। उसको फिर हम अच्छा उसकी हमने वो फिर
Factorize
फैक्टराइज नहीं,
middle term breaking.
फैक्टराइज किया। ओके ओके ओके, ठीक हो गया।
So you got the other two linear factors as well.
हम्म।
You wanted the three linear factors, one they had already given to you, and to find the other factors, you needed the quotient. And to find the quotient, you did the long division. And after long division, you got the quotient, and you factorized the quotient, you got the other two.
other two quotient. Okay.
Okay, these are also very generic types of, again, repetitive questions. You will see a lot of questions like these. The polynomial ax cube plus bx square plus 5x minus 2 is denoted by px. So there are, you can see two unknowns which you want to find, a and b. And it is given you that 2x minus 1 is factor, and it is given that x minus 2 gives the remainder 12. So this means that using these two conditions, you can form two equations. And then using the two equations, you will solve them simultaneously and get the answers to the two unknown. So if you have 2x minus 1 is equal to 0, so your x will come out as 0.5. And because it is a factor, this means that function p, and if the input is 0.5, the resultant would be 0 because it is a factor. And if x minus 2 is equal to 0. So x is equals to 2. So if your function inside your function you input the value of x as 2, you will get the remainder as 12 because they have given the thing. So you will form these two equations, simplify them, form quadratic, simultaneous equation, solve them. So this would become 0 is equal to 0.5 cube x, a plus 0.5 square b plus 0.5 into 5 minus 2. And you can use a calculator to simplify these things. So 0.125a, 0.25b, and this would become 2.5 minus 2.5. So minus 0.5 equals to 0.125a plus 0.25b. This is your first equation. Now you will use P2 and it is 12 is equals to 12, and if your x is 2, so 2 cube a plus 2 square b plus 5 times 2 minus 2. So this would become 8a plus 4b plus 10 minus 2 equals to 12. So 12 minus 10 plus 2. So 4. 8a plus 4b. And now you will solve them simultaneously. You can use your calculator to solve them simultaneously. So 0.125, 0.25, and minus 0.5. Sorry. This is 8, 4, 4. So your value of A is coming out as 2 and B is minus 3. That's it. This is your answer. And you can input these values back again. Then they're asking you, when A and B have these values, find the quadratic factor of Px. This becomes now your function Px has become A is 2x cubed minus 3x squared plus 5x minus 2. And we already have one factor. 2x minus 3 was the factor. And they're asking you to get the quadratic factor. So you need the quotient, right? Your long remainder factor theorem doesn't give you the quotient. If you want to find other factors of a particular polynomial, you will need to do the long division. 2x cubed minus 3x square plus 5x minus 2 and 2x minus 1. You will multiply it with x square. So 2x cubed minus x square, change signs, cancels out, minus 2x square plus 5x. We will multiply this thing with minus 2, or no, minus x. So minus 2x square and plus x. Again, change signs, cancels out, 4x minus 2. And this would now be multiplied with plus 2. So 4x minus 2. Change the sign. So 0, 0. So your remainder, look, it is coming out. Because you are dividing it with the factor, the remainder should come out as 0. And this is the answer to your last part. This is your quadratic factor, the other quadratic factor. Okay. Any questions?